This is based on the exam LPM Fall 2019, question 10A. And so here we have the expected return and the standard deviation of 3 portfolios. And the company has a risk aversion level of 4, which means they are not very risk averse. They're just kind of medium. And then they said that they must exceed a return of 5%. So that's their hurdle rate. You could consider that their risk-free rate if you're looking at the formula, but we're going to use this 5% for their hurdle rate. And then we need to recommend portfolios based on the risk-adjusted expected return and the Roy's safety first criteria. And now the Roy's safety first, that doesn't use the risk aversion, and vice versa. The risk-adjusted expected return doesn't use the hurdle rate right there. So, I mean, it makes sense that you don't use the hurdle rate. It's just like this is essentially looking at subtracting the variance, a variance of the expected return. So this formula, the way I can remember it, is that you have the risk aversion and you multiply it by the variance. So you use the expected return minus the variance times 1/2 of the risk aversion. And so here you can see that the highest expected return portfolios B and C tie right there. So there's 4%. So you say, oh, just look based on the first one, it's B or C. And then the Roy's safety first criteria, this is counting how many standard deviations away of the difference between the expected return and the hurdle rate. And so you see that this one is just barely higher. These are really high standard deviations right there. So that's why we have it pretty low right here, but we recommend portfolio B. So if using both of them, both criteria, you would recommend portfolio B. Now let's suppose that this company was risk averse. So that would be like an 8. In this case, this goes negative because the standard deviation, the variance, is getting a bigger impact. And so that way, you'd only recommend the one that the standard deviation is playing a bigger impact on the expected return, because this one has the smallest one, it decreases the least, and so that would be right there.